All right, so what we're going to do today is take a look at some review questions from our 45, 45, 90 right triangles, and then we're going to introduce our next triangle, which is actually called our 30, 60, 90. So today when we're going over our 45, 45, 90, I am not going to do any of the Pythagorean theorem stuff. We're going to do straight formulas for our special rights. Again, don't forget with what we looked at on Monday, we said you could do the Pythagorean theorem with our isosceles triangles. Today, just going to use our 45, 45, 90 right triangles. So, um, make sure, hi Siona, make sure when you're looking at this, you don't forget about the Pythagorean theorem, but you do keep in mind that our formulas are supposed to be faster. So the first thing that I want to do when I think about my formula for our 45, 45, 90 is I want to make sure that I do remember that it's an isosceles triangle because they're only going to show us the angles, so that does mean I'm allowed to put my tick marks on the sides. Opposite these 45-degree angles, we are going to use the same variable, A and A for their example. I could have done D and D, or Q and Q, M and M, doesn't matter. Opposite the 90-degree angle will be that variable times radical 2. So we have this 1 to 1 to radical 2 situation. So it's this formula that I want to use. So here's our example. We have one side is 12, we want to find x and we want to find y. And the first thing I'm going to recognize is because these are the same, they do fit that 45, 45, 90 situation that we're trying to work with, which also means we have our isosceles sides. And I'm going to write the same formula around this the same way I did here. Opposite our 45, we're going to put A. Opposite our other 45, we're going to put A. And opposite our 90, we're going to do A radical 2. Notice each time I do this, I find the angle and I go opposite. I find the angle and I go opposite. I find the angle and I go opposite. So I am physically showing how I'm going to label this according to where my angles are and what side is opposite. The next step that I want to do is I want to figure out what side has my formula and what side has the value. That's that side. We have A and we have 12. We're going to take that and we are going to set them equal to each other. A equals 12. Now the nice part, there's no work to be done. We have already figured out what A is. So that means on this side, it's 12. And over here, we're going to plug 12 in for A and rewrite the radical 2. No work, because we've seen the pattern, we're going to fill it in. The only thing that I am going to ask is when we get to any written work, I don't want to have to figure out in here amongst all of your work what your answer is. Write it out. X equals 12. I have it right here. Y equals 12 radical 2. Box it in. And that way there's no question as to what our answer is. Probably the easiest question you can ask with a special right that's a 45, 45, 90, in that you already know what the variable is, just plug it in. There's no guesswork there. So let's look at another example. Let's turn our triangle a little bit. Change it up just a little bit. And again, we're going to find x and y. move that guy up now that we've had time to look at the other example. And same steps. Going to figure out what kind of triangle this is. Well, this is 90. That means these two have to be complementary, meaning they have to add up to 90 degrees. So if that's 45, the only other number that's going to match is 45, which means they're congruent. So I'm going to put my tick marks opposite them to show that they are also congruent. I next write our formula around it. So we know opposite the 40-degree angle is 1 of something. So instead of a's like we did in the last example, I'm going to make this g, which means this side is g, and this side is g radical 2. So again, it's our formula just like we had a, and a radical 2. Now it's g, and g radical 2. It's not the variable in our formula that matters. It's the 1, and radical 2 relationship that we want to concentrate on. And just like before, the side that has the formula and our value, the number, we're going to set equal to each other. So g radical 2 equals 27 radical 2. Now, Siona, you might already see what this answer is, and others may as well, but just to show why it's happening, just realize that what we have is when we divide by radical 2 on both sides, it'll cancel here, and it cancels here. Radical 2 divided by radical 2 is 1. So we're left with g equals 27. So that means this side has to be 27 and this side has to be 27. So when I write my final answer, x equals 27, y equals 27. And we're done. So again, the pattern can make this go by a lot faster. You might be asking, do I have to show all this work if I already can see that it's happening? Absolutely not. That's the point of this being a shortcut. When you see it happen, answer the question, move on. All right, so let's take a look at another example. Again, just reviewing what we talked about on Monday. All right, so we have our hypotenuse is 14, and our side lengths are the ones we're trying to find. Our legs are x and y. So, same steps. Make sure we understand what our numbers are. Well, again, if they're congruent and they have to add up to 90, they have to be 45. Which means the sides opposite each of those 45-degree angles have to be the same, so that's why it makes it isosceles, which then allows us to do our formula around the triangle. Opposite our 45, let's do E. Opposite our 45, E. Opposite our 90, E radical 2. So notice again, it's 1, 1 to radical 2. So it's a 1 to 1 to radical 2. The letters don't matter. It's where we put the numbers. So A, and A radical 2. Up here was G, and G radical 2. E, and E radical 2. It's all about how many are on each side. And, of course, just like all the rest of them, we find the side that has our formula and our actual value, the known number. We're going to set them equal to each other. Well, I'm running out of room down here, so let's do E radical 2 equals 14. We need to get e by itself, so we're going to divide the radical 2 away. We know it's going to cancel on this side, and we end up with e equals 14 over radical 2. No, no, no. Sorry, I'm not talking to you, Siona. I am explaining that there can be patience in my house. So 14 divided by radical 2. This is not where this has to stop. This needs to be rationalized, which is our fancy word for get the radical out of the denominator. So in order to do that, we need to change 2 to a perfect square. Well, the easiest way to do that is to multiply it by itself, because anything times itself will give us a perfect square. But to keep this value of 14 divided by radical 2 the same, we have to multiply by 1. We want the value to stay the same, we just need it to look different. Well, this is the number 1, so anything times 1 will remain itself. So we're going to multiply straight across, and we end up with 14 radical 2 over the square root of 4. So notice that our radical 2, which was in the bottom, has now appeared up top. So our 14, which was the numerator, radical 2, which was the denominator, are now both up top, and the square root of 4 is 2. Notice that's the number that's inside here. This pattern, every time we rationalize, will be the same pattern every time. Numerator stays the same, the radical appears in the top, and just the number is now on the bottom. So the only other thing I have to do here to solve for e is just make sure that I reduce. The 14 over the 2 can simplify, and that is 7 radical 2. Now, there are some of us out there, to be quite honest, that will be able to jump from here to here when we start recognizing that pattern will repeat. So now everywhere I see e, I get to plug in 7 radical 2. So over here is 7 radical 2, and over here is 7 radical 2. So when I write my final answer, x equals 7 radical 2, y equals 7 radical 2, and I box it in so there's no question what my answer is. All right. So what I want to do now, because again, this just, and what you're going to find, and I know right now looks like someone else has joined us, but these 3 examples, I'm going to zoom out for a second, do go with what we did on Monday. I wanted to make sure that we had a bit of review. You are going to find when I post this to Google Classroom that I will also post what I did in the geometry class earlier today so that you can see both set of notes. What I want to now do is look at a few other questions. We're going to zoom back in here. But this time, we're going to talk about what's called 30, 60, 90. It's the only other special right triangles that we have. Now, I'm not going to go through the Pythagorean theorem example on how you could use the Pythagorean theorem with this. It's honestly very involved. It involves a lot of quadratic equations and examples that we don't need, because I really think After looking at how these formulas worked for our 45, 45, 90, I really think looking at our formula that we're going to see for this one, it's going to be pretty easy to work with. So we're going to draw a triangle that is definitely scalene because, again, the three angles are all different, so our triangle is different lengths. So we're going to put a 30-degree angle up there because that guy looks like he's smaller. We're going to put a 60-degree angle down here. He looks bigger. And we have that 90 degrees. So 90 between the 30 and the 60 plus 90 is our 180. Our side lengths are then different. So opposite our 30 should be our shortest side because 30 is our smallest angle. Opposite our 90 should be our longest side. Not only is 90 our biggest angle, but I think we know by now that the hypotenuse should be the longest side. And opposite the 60 is kind of the guy stuck in the middle. 60 is the middle measure. That side would have to be the middle length. And that's always a good thing to pay attention to because we've done our triangle inequality stuff so much recently that we should know opposite the smallest should be the shortest, opposite the middle guy should be the middle length, and opposite the largest should be the longest. And that's very important because our 30, 60, 90 right triangles will have a consistent ratio for the side lengths. And that is a 1 to radical 3 to 2 ratio. So just like we saw with our 45, 45, 90, where we said it was 1 to 1 to radical 2, now we have our shortest side is going to be 1 times something. Our middle side is going to be that something times radical 3, and our longest side is going to be 2 times that something. So watch how I do this, because again, it's very important that we find the angle and we travel across from it, and our shortest side is going to get 1 of something, so A. Our middle length, we're going to travel opposite it, and it is going to get whatever that value is times radical 3, so A radical 3. And opposite our 90-degree angle, we're going to travel opposite it. Notice that I am physically going opposite to the hypotenuse. That is going to be 2 times our something, or 2A. So we're going to have our formula, again, around our triangle. Opposite the 30 is A, 1 times A, A. Opposite our 60 is A radical 3, so radical 3 times something. And opposite, our 90 is going to be our 2A, or 2 times something. So make sure we're traveling opposites. All right, so the first thing that I want to do is I'm just going to have us practice looking for opposites. So here's our first right triangle. Here's going to be our second. And here is going to be our third. And what we're going to do is we're going to practice putting our formula around the triangles. First thing I'm going to suggest is right away put your 60-degree measure in there because we know 30 plus 60 is 90 plus 90 is 180. Then start with your different color because we want to be able to see our formula. I'm going to find the 30 and I'm going to go across from it and we're going to put A. Maybe Siona, you like S, so you use an S, or you like W for Wilson, use the W. Opposite the 60 is going to be whatever letter I chose times radical 3. So opposite the 60 is A radical 3. Opposite the 30 is A. Opposite our 90 is 2A. So every time I work with what's opposite. So let's do the next one. Same idea. Let's just put our ratios in. I'm going to put our 30-degree angle in there. I'm going to use a W this time, but we're going to start the exact same way. I find my 30-degree angle, and I'm going to go opposite and put a W. I'm going to find my 60-degree angle. I'm going to go opposite and put W radical 3. And I'm going to find my 90-degree angle and go opposite, and that's going to be 2W. Turned our triangle again. Let's practice our ratios. I put my 60 degrees in so I have something to look at. I'm going to use a C this time for calf. I find my 30. We're going to go opposite the 30. C. Opposite the 60 is C radical 3. Opposite the 90 is 2C. So again, we have to make sure that our formulas go to the correct side because again, opposite the smallest angle should be your shortest side. Opposite your largest angle should be your longest side, and that guy in the middle, opposites should also match. So that's just something that I wanted to make sure that we don't make the mistake. That's going to be huge. Now, every example that I do after this, you're going to see that the steps are the exact same steps as our 45, 45, 90. Nothing's going to change. Only thing that changes is the formulas we use. So notice I'm putting a 60-degree angle in there. And we're going to find X and Y. First thing, check what kind of triangle we're working with. So that is check your right triangle. Which formula? And by that, it could be, is it 45, 45, 90? Is it 30, 60, 90? Could I use the Pythagorean theorem? At this point, that's what we're looking for. And honestly, at this point, we could even say, could we use our altitude on hypotenuse if I had a segment going in the middle? You don't see any of that. You don't put it in, but you checked your triangle. Second thing you're going to do, you're going to fill in your formula. and put it in a different color. That way it's easier to see. It's going to help you out. So we know that for us, we picked 30, 60, 90. So I'm going to make sure that I put my 30-degree angle in so I don't make any mistakes. And I'm going to find that 30-degree angle, and opposite it, I'm going to put A. I'm going to find my 60-degree angle, and opposite it, I'm going to put A radical 3. Opposite the 90 is going to be 2A. Third step, just like we did with our 45, 45, 90. Circle the side that has the value and the formula. So just like we did before, circle the side that has the value and the formula. And then solve. So A equals 18. There's nothing to solve. So everywhere we see A, we're going to plug in 18. So you can see how this is almost identical to what we just got done doing. So we're going to plug in 18 over here, and this side is 18 radical 3. We're going to plug in 18 over here, and 2 times 18 is 36. So I'm not going to search the triangle for this, but we are going to then label appropriately that this side is 18 radical 3, and this side, y, is 36. And we're done. So we looked at our triangle and decided which formula is going to work best. Once we figured out that formula, we put it around our triangle, we circled and solved, and then listed our answers appropriately. So, a couple more examples and we're done, but you're going to see that I'm going to go through those 3 steps every time. All right. Question is pretty much the same. I just, instead of using variables, we used segments. So we want to find the length of AB, and we want to find the length of BC. First step, what kind of triangle do we have? What formula can we use? Well, I already see a 30-degree angle in here, so I'm going to put my 60-degree angle to finish off my triangle. And I realize that it's a 30, 60, 90. So opposite the 30, we're going to put A. Opposite the 60 is A radical 3. Opposite the 90 is going to be 2A. We looked at the triangle to figure out which one it was. We put our formula in accordingly, and now we're going to circle and solve. So 2A will equal 42, and when we divide both sides by 2, we find A is 21. So that means everywhere I see A, I'm going to plug in 21. So over here, we can see it's 21. And over here, we can see it's going to be 21 radical 3. And what's nice, no extra work has to be done. And we write our answers carefully, proofreading not to plug the wrong one in. 21 is on the side that AB is. 21 radical 3 is the side that BC is on. And I do want to double check to make sure it even makes sense. Is 21 smaller than 21 radical 3? Well, yeah, because we're multiplying something here with 21, so it's going to be a little bit bigger than this guy. And that makes sense because 30 is our smallest side. 60 is bigger, so it's got to be longer. And then our longest side would have to be opposite the largest angle. So double check that you're doing that as well, because I will say from many years of experience, students will get the right answers and interchange them when they plug them in. And whether it's on a written test or in what eventually will be our no reassignment, you interchange them and it's wrong. So we have to make sure that we do proofread that. All right, let's take a look at another example. Trying to give us a ton of things to look at so we don't have as many questions when we come back together to do this again. Let's draw another right triangle. All right, a little bit different. This time we're actually asking you, what is the measure of angle Y? A lot of times they'll say solve the right triangle. Solve the right triangle pretty much means whatever you can fill in, fill in. And that's big. If you see solve the right triangle, that means find everything. Angles, lengths of sides, everything. So here I just kind of spelled it out for us. Apparently I'm writing uphill. Sorry. We're going to name angle Y. We're going to find the length of these two sides. Well, we already know our pattern, so angle Y is going to be pretty easy to fill in. We then pick our formula. If it's 30, 60, 90, we know opposite the 30 is A. Opposite the 60 is A radical 3. And opposite the 90 is 2A. So again, we circle our answer, the number that we have, and set them equal to each other. So now that we're going to set them equal to each other and we're going to solve, we have A radical 3 equals 31 radical 3. Now, Siona or whoever else is following along, you may already know what A is. That's great. So just like our 45, 45, 90, if you already see that A is 31, plug that guy in, finish the question fast. But I am going to show you the reason why it works is that we divide away that number, that radical 3, and it cancels. So what we're left with is what we thought we saw. A is 31. So wherever you see an A, you're going to plug in 31. So we're going to have 31 over here. And we're going to have 2 times 31 over here, which is actually 62. So when we go back to answer, make sure we answer everything. The measure of angle Y is 30 degrees. The length of XY is 31. And the length of WY is 62. We write all those out. So far, and truly, most of our answers, just like our example with our 45, 45, 90, our isosceles right triangles, they are supposed to be pretty quick. That's why these shortcuts, these formulas come in so handy. What makes things go a little bit longer is when we have to rationalize, because we end up with that radical sticking in the bottom of our problem. So our last example is going to look like this. And we're going to solve the right triangle. So again, remember what we just got done saying. When we solve the right triangle, find all unknown measures. So that means the measure of angle F, the length of EF, and the length of DF. Oops. Shouldn't have that guy there. Get my hair. No haircuts, so he has hair. All right. So solve the right triangle means find all the unknown measures, the measure of F, the length of EF, the length of DF. So we look at the triangle and we decide what formula is best for what we're doing. It's not the Pythagorean theorem. We only have one length. Can't do it. It's definitely not 45, 45, 90 because it's not isosceles. So we have our 60 degrees. And then we do our formula. So opposite our 30-degree angle, I'm going to say is X. Opposite our 60-degree angle is X radical 3. And opposite our 90-degree angle is 2X. Remember we said we can use any variable as long as it's 1, radical 3, and 2. And the 1 of something is opposite our 30. The radical 3 of whatever we've chosen is opposite our 60, and the 2 times that something is opposite the 90. And again, find the side that has our value and our formula and set them equal to each other. So X radical 3 is equal to 19. In order to solve, we're going to divide by radical 3. And this time, it cancels here, but it doesn't cancel here. So we're left with this answer where we have a radical in the denominator, and we know that that's not appropriate. So we have to, because it's going to be our final answer, we need to rationalize. So we're going to multiply top and bottom by that same value to make it our perfect square. And notice how our radical now shows up on top, and our denominator is a perfect square. 3 times 3 is 9. So we have 19 radical 3 over 3. And unfortunately, it doesn't reduce. So we end up with X equals 19 radical 3 over 3. Now, what we have to do is we still have to plug X in. So we found out that our formula, 19 radical 3 over 3, is X. We have to plug that back in. So that gets plugged in over here for X. 19 radical 3 over 3, and it gets plugged in over here. 2 times 19 radical 3 over 3. The 2 and the 3 aren't going to cancel. Now, if you need scrap paper to do this, use scrap paper. I'm going to bring my scrap paper over, and you have 2, oh, that's an ugly 2, 2 times 19 radical 3 over 3. It's like a fraction. So everything on top multiplies across, and you end up with 38 radical 3. And in the denominator, 1 times 3 is 3. So if you need to show that happening, do that on a scrap piece of paper, or maybe you have a section on your paper where you do your scrap work, and you can do 2 times that 19 radical 3 over 3, showing that it's a 2 over 1, and then you go straight across, and that's where you end up with your 38 radical 3 over 3. So however you choose to do so, make sure that you get your right answer, which is 38 radical 3 over 3. Now we got a lot going on here. The bulk of our work was because we had to rationalize, just like we did with our 45, 45, 90. So please make sure when you write your final answer, you write it someplace clear so that when you answer it, we're not searching as we're going. So we said angle F was 60. I'm looking for the length of EF, which we knew was 19 radical 3 over 3. And now we have DF as 38 radical 3 over 3. And so the bulk of this work is the rationalizing. Now, you are going to find that a lot of the questions are going to be pretty straightforward, like you saw previous, but we know that our standardized tests, the further we go in math, as much as we don't like the no reassignments in some cases, they do help us realize that these are the numbers that are going to show up more often. Not nice, neat, comfy numbers like 30, 32, 62, 31, whatever. The radicals are what's going to come up, these improper fractions. So please make sure that as you are looking at your notes, that you are practicing the steps and the formulas. So I am not going to add another assignment this week. However, just know that for those of you that want to get a jump start, I am going to give you the no reassignment ahead, but I am going to not require it until a little bit later, so that you can kind of work next week, this Friday and next Monday, in asking the questions that you need. So with that, please check Google Classroom. Make sure that you go back and rewatch some of the videos. That way you can pause or rewind if necessary. I am going to load the honors geometry notes. Yours are definitely a little bit more involved, and there are more examples, but I'm going to give you the honors geometry notes as well so that you can kind of look for other examples. I'm also going to put in Google Classroom a study guide from our book, but the study guide is going to have the answers. It is not required. It is just an opportunity to give you a couple practice problems with the answers there to see if you're doing them right. So if you need more practice, those are there. So with that, I will talk to all of you Friday or Monday, so please stay on top of things, and I hope to see more of you at the next class. Thank you, Siona. I hope I was able to help, and if you have any questions, please email.